We're just looking at a few concepts today with inverse functions. The first one that we're looking at is mutually inverse functions. Now, as we discussed last lesson, inverse operations undo each other. So inverse operations undo each other. For example, if I've got the square root of x and then I square it, okay, so if I take the square root of x and then I square it, that is the same as squaring the x and then square rooting it. Do you remember that? From, year 9, year 10. So, for example, if x is 9, the square root of 9 is 3, 3 squared is 81. If x is 9, 9 squared is 81, the square root of 81 is 9, okay? So a function and its inverse are what we call mutually inverse functions. Now what that means is the following. So a function and its inverse are mutually inverse functions. That means, that is, that the inverse function of the function of x is equal to the function of the inverse function of x. So the inverse function of the function of x, you need to look at the screen, is equal to the function of the inverse function of x, which will equal x. Now, the best way to show this is if we do an example. Okay, for example, show that function of x which equals x squared and its inverse are mutually inverse functions. Now, if our function of x is x squared, do you know what its inverse is? We can replace the y with an x and the x with a y, and anyone know what's the opposite of squaring, or the inverse function of squaring? Yeah, it's square rooting. So the inverse function will be the square root of x. Wait, I'll show you. We don't need to do the plus or minus here. I can, but we're going to end up squaring it anyway. Okay? So if you're not sure, let's just check. If y equals x squared is my function, what you were doing last night, the inverse function is x equals y squared. So y we know is plus or minus square root of x. All right? But if we're just saying what's the opposite of squaring, it's square rooting. I'm just saying purely just the opposite of squaring is square rooting. I'm not going to put the plus or minus here, okay? So remember, this is the rule to show that a function and its inverse are mutually inverse. So the inverse function of the function of x. So the inverse function is to take the square root. So f to the minus 1 of the function of x is, what do I write first? Do I do the square root first? Yeah, that's my main function. So I do square root of, now what's the function of x? So inverse function tells me to square root my function. So function of x is x squared, okay? So, which is, or I can write that as, wait a sec if you want, I can write that as its function to the minus 1 of x squared. Are we okay with that? Which is the square root of x squared. So inverse function of function of x is inverse function of function of x is x squared, which happens to be the square root, because that's what the inverse function is telling me, to square root whatever I've got, square root of x squared, which is x. Okay? The function of the inverse function, now the function is telling me to square. So it's the function of, what's the inverse, so this is asking me to do the function of this inverse function. Now the inverse function is square root x. Now the function is telling me to square. So I've got square root of x squared. Okay, the function is telling me to square. So see, this inverse function here bit, that's like what my x is. You know how, if I ask for the function of 2, you plug in 2 wherever you've got the x. Okay, here I plug in the inverse function wherever I see x in the original function. That's what you plug in. In the first one, you're plugging in the function of x into the inverse function formula. Okay, now if you compare, inverse function is square root of whatever you've got there. So it'll be inverse function of the function of x. The function of x is x squared. So it's the square root of the x squared. Gives you x. This one is the function of the square root of x, which is the function, which is, sorry, now I'm getting all confused. The function is to square whatever you've got. So the square root of x squared, which is x. I might do it with another one. Might be a bit easier than that one. All right. The inverse of the function is equal to the function of the inverse, which equals x. Okay, so therefore they're mutually inverse functions. So therefore function of x and inverse function of x are mutually inverse. We'll look at another one. Y equals 3x plus 4 and its inverse are mutually inverse functions. So your function of x is 3x plus 4. What's your inverse? Can you, x times 3 plus 4? It doesn't matter if you can't do it like that. We'll just swap x's and y's and make y the subject. What do you get? Remember? So that's your function. What we were doing for homework yesterday, that's the inverse, swapping x's and y's and making y the subject. What if x minus 4 over 3 is your inverse? So function of x is 3x minus 4. The inverse function is x minus 4 divided by 3. So we need to do the inverse function of the function of x. All right, how do I set that one out? How do I set that one out? Do I sub this into that or that into this? What's my main function? It's the inverse, so I start writing that one out. Okay, so I want to do the inverse of 3x plus 4. The 3x plus 4 is going to get substituted in. Do we get that? It's the inverse of the function of x. So it's the inverse of function of x is 3x plus 4. So the 3x plus 4 gets substituted into the inverse function. So I replace the x with 3x minus 4. Got it? Minus 4. Oh, no, 3x plus 4 minus 4 over 3. Got it? Do you see that? We start with this one. So inverse function of the function of x, that's the inverse function of 3x plus 4. The 3x plus 4 gets substituted into the inverse function wherever the x is in there. So, do we get that? So, which is what? 3x plus 4 minus 4 is just? Yeah, it's just... Because I substitute the x in here for 3x plus 4, then I've got minus 4 for the rest of... I'm substituting the 3x plus 4 into this. So the x gets replaced with 3x plus 4. It gets replaced with, see, I'm using the inverse function and I substitute the function of x into any x's there. So I get 3x plus 4 minus 4 is 3x over 3, which is x. Now, the function of the inverse function, so that's telling me start with my function, which is 3x plus 4, but I'm substituting the inverse function into it, so it's the function of x minus 4 over 3. So this one tells me to start with the ordinary function, which is 3. Where now for this, with this x, I substitute in this x minus 4 over 3. X minus 4 divided by 3, then plus 4. Okay, start with the original function and substitute the inverse into the x value up here. So it's 3 times x minus 4 divided by 3 plus 4. What happens with the 3's? Cancel, and I've got x minus 4 plus 4, which is x. So therefore, they're mutually inverse functions because... So the definition for mutually inverse functions are because the inverse function of the function of x is equal to the function of the inverse function of x. That's the definition. As domain and range of inverse functions, y equals 3 divided by x minus 2. This is a hyperbola. What's the vertical asymptote? I'm just going to draw it here. Yeah, vertical asymptote is 2. Which quadrants is it in? First and third. It looks like this, doesn't it? Pretty sure that's what it looks like. When x is 0, what's y? Anyway, it's down here. What are the asymptotes? Oh, what's the domain? Do you remember how to draw those, girls? Yeah, so the domain of the function, so I'm going to go the function, that's the original function. Domain is all real x. X cannot equal 2. So they're the x values. And the range, so that's domain. Yeah, the range is all real y, comma, y cannot equal 0. Okay, now that's our original function, function of x. We're going to draw the inverse function, and we're going to, and we're also going to write down its domain and range. Okay. I'm now going to look. Can you see red or not? The inverse function. How am I going to work it out? What it is? Swap the x and y. X equals 3 over y minus 2. What's a nice quick way to do that? Swap. Y minus 2 equals 3 over x. Good with that? So the inverse, swapping the x and y values, it's just easy to put this whole thing up there and move the x back down. So y minus 2 equals 3 over x. Remember, we're trying to make y the subject. So y equals 3 on x plus 2. So that's my inverse function in red. Y equals 3 on x plus 2. All right, we have to think what sort of function is that and what is its domain and range. Now, what you would normally do, once you know the domain and range of this, you swap it and you just say, but we're going to do it. We're going to do it properly, and then you're going to see the pattern, and then you'll be confident to do the swapping. So, what's this? It's a hyperbola, yeah. Which quadrants? 1 and 3. And it's shifted up 2 units. So this time there's no, there isn't a vertical asymptote. Well, there is. Well, there is. But the x equals 2 asymptote here becomes the y equals 2 asymptote there. That's what I'm trying to say. So our asymptotes here are x equals 2, y equals 0, but we're going to have a swap of that. We're going to have y equals 2, x is 0 as our asymptotes in our new one. So there's 2. So wouldn't I just draw it here and there? Because when y is the subject, I can just draw it normally with my y and x axis. It's 3 over x, which would look like that, and it's shifted up 2 units. So my new function has domain. My new function has domain what? All real x, comma, x is not equal to 0. So, and it has range, all real y, y is not equal to 2. So you can see now what's happening. With the original function, the domain was all real x, x can't equal 2. Our range for the inverse is all real y, y can't equal to 2. Just make sure you swap the x's for the y's when you do that. Got it? And in the original function, the range was all real y, y can't equal 0. And the domain of this is all real x, x can't equal 0. Because we know that inverse functions are when we swap our x with our y values. So the domain and ranges will also be swapped. All right? Okay. So therefore, you can just put a little box note that the domain and range of inverse functions, so the domain and range of inverse functions are the reverse, are the range, I might just put are the range and domain, which is the other way around, of the original functions. So I've gone domain and range of inverse functions are the range and domain of the inverse function, just the other way around. They're swapped, basically. Okay, so there's no need, so you basically just need to work with the original function. You don't need to sketch the inverse and work out its domain and range. You can just make that conclusion straight from knowing the domain and range of the original function. You actually don't need to work it out for the inverse. All right? Domain and range of the function y equals ln x and its inverse. That's what I'm trying to say. So your function is y equals ln x. Oh, do we know how to draw that one? Do you know how to draw the log ln x? Yeah, it's down like, actually I do want to talk about this one, because I never did. Yeah, it's the opposite of what? It's the reflection of e to the x. Actually, I want to do that one up on Desmos in a minute. So girls, remember, you know, from all our work on logs, whenever we did the log of anything less than 1, all right, log of a negative is undefined. If you do ln negative something, there's an error, undefined. Log of anything between 0 and 1 is negative. Remember? Log of 1, ln 1 is 0. Okay, ln 2 is some number, whatever. So this is the function y equals ln x. Just from what we remember that inverse functions are reflection, you can draw it by reflecting in the line y equals x. I should be able to draw the inverse function here. You know how this is the point 1, 0? Well, its matching point is the point 0, 1. Now, you did this last night as part of your homework. The inverse function would be x equals ln y. How do I make y the subject? I should do that in red. How do I make x the subject, y the subject? Take e of both sides. E to the x equals e to the ln y, which is y equals e to the x, is the inverse function. Now we know what y equals e to the x looks like. When x is 0, y is 1. When x is 1, y is something like 3-ish, 2.7. Looks like this. And if you try something like if x is -2, it's down here. But basically, the function y equals e to the x and y equals ln x, they're inverse functions of each other. Okay? Now, we're going to do the domain and range of each. So for the function y equals ln x, the domain is, and the range is, and we're going to look at the function so our inverse function is y equals e to the x. We're going to look at its domain and its range. Okay. Of course, you would only need to do the original function. You wouldn't need to do the inverse. But this is a really specific case. We should know what the inverse function of y equals ln x is, all right? You've done, you know, when you were doing all your log problems and you were trying to solve for y, you take e of both sides. That's the inverse of the log function. Okay, domain of the y equals ln x. What is it? X values are x is greater than 0. Yeah. Okay, what about the range of the blue one? All real y. I mean, it'll, you know, take a long time to get to high values of y, but it is that. So therefore, without even looking at the graph, what will be the domain of this, of the red one? What will be its domain? It should be all real x. We'll have a look at the graph in a minute. And the range should be y is greater than 0. So we take this domain and change the x for y, and that will be the range. So let's have a look at the graph. Is that true? The domain is all real x, and the range is y is greater than 0 for the red inverse graph. All right? But from now on, you won't need to do that. But you should know that y equals ln x and y equals e to the x are inverse functions of each other. Yes, I've done original function in blue. It will have an inverse because it's, see the curve y equals ln x? It's called monotonic increasing function. It's a monotonic increasing function because it's always increasing. All right? See the gradient? Always increasing. This is leading us on to the next exercise. This function, y equals 3x minus 2, what's the gradient of that? Increasing or decreasing functions have got to do with the first derivative and the gradient. Tell me about the gradient here. It's negative. Same with this. If the gradient's always negative, so it's monotonic decreasing. One mono, one type. Monotonic decreasing function will have an inverse. Monotonic increasing function, will have an inverse. However, if it's not monotonic increasing or decreasing, it'll have an inverse relation, but not necessarily an inverse function, unless you restrict the domain, which is what we're going to look at now. Okay, we're now just going to look at monotonic increasing and decreasing functions, and where a function does not have an inverse function, we're going to look at restricting the domain of those functions. Okay, so if y equals function of x is a 1-to-1, which is a monotonic increasing or decreasing function. Now I'll explain does anyone know what 1-to-1 means? For every one x value, there is one y value. And for every one y value, there is one x value. That's what 1-to-1 means. Now, y equals x squared is not a 1-to-1 function. Because, so if y equals function of x is a 1-to-1, which is a monotonic increasing or decreasing function, with domain x lying between a and b, and range function of a, y lying between function of a and function of b, then the inverse function, which is y equals f to the minus 1 of x, we already know this, has domain function of a less than or equal to x less than or equal to function of b, and range. Remember that your y value is your domain, and how do you find y? You substitute different values of x to get your function of x. You know how y is function of x? All right, that's what that's saying. So if the domain is from a to b, and the range is from function of a to function of b, because that's how you find your y value, you substitute in different x values, then the inverse function has domain function of a through to function of b, and range a to b. Y lies between a and b. You already know this. Now, I already wrote that before, but that's just written formally. Now, 1-to-1 means, I will. All right. For every x value, there is only one y value. That's what 1-to-1 means. For every x value, there's only one y value. It means for every x value, there is only one y value. A function that is not 1-to-1 does not have an inverse function. For example, y equals x squared. We touched on this yesterday. But what we're going to do, if you look at y equals x squared, I can see when x is 1, y is 1. But when x is negative 1, y is 1. All right? So for every x value, there's only one y value. I'm going to put, and vice versa. For every y value, there's only one x value. All right? Because once I turn that sideways, see here, the same y value has two x values, so it's not 1-to-1. You okay? All right? So for example, here I've got 1, 1, but here I've got negative 1, 1. So that will not have, that function is not 1-to-1, so it won't have an inverse function. So we're going to restrict the domain. So this does not. See, when x, well, let's just say for y equals 1, x is plus or minus 1. That's the problem there. It's not 1-to-1. One y value, two x values. So this is what we're going to do. So restricting the domain. See, girls, the problem with this, what have I got here? Increasing, decreasing. That's the problem with the function. The function y equals x squared, for its whole domain, is increasing and a decreasing function, is increasing and decreasing. That's the problem. That's why it has no inverse function as it stands like that. Look, increasing here, decreasing there. Got it? So therefore it's not monotonic. It's not monotonic increasing or decreasing, all right? And not monotonic. Not monotonic increasing or decreasing. That's the problem with it. It's got to be one or the other. And you can see that it's not. It's both. See, I said up in that box earlier, if the function is a one-to-one function, it will have an inverse function. But this is not a one-to-one because it's increasing and decreasing, or the two, when y is 1, you've got 2 possible x values. When y is 4, you've got 2 possible x values. So this is how we're going to restrict it. The easiest way, make sure it doesn't have a turning point. So here we go. Let's take the first bit. There's the first bit. So that, if I just take the right-hand side of the y equals x squared graph, it now is monotonic, increasing or decreasing. Okay, so let's look at this bit. So if we look at y equals x squared for x greater than or equal to 0 only, got it? Only looking at that right-hand side. So if we look at the domain x greater than or equal to 0, what would be the range of that? Yep. And now it's monotonic increasing. So we're going to restrict the domain. We're going to look at y equals x squared for x greater than or equal to 0. If we only consider that, then domain x greater than or equal to 0, range is y is greater than or equal to 0. It's monotonic increasing. Therefore, it has an inverse function, and we can draw it. Let's put some points. When x is 1, y is 1. When x is 2, y is 4. How's the inverse going to look? How do you swap 1 and 1? 1 and 1. Good. And how do you swap 2 and 4? 4 and 2. So make sure, so for the next, it'll look like this, the inverse. Can you see it coming? Are we okay? And if I put the dotted line in the middle, there will be the dotted line of y equals x going through. All right, let me make that bigger. Okay. So now my inverse relation is x equals y squared, but that's the relation at the moment if I drew the whole thing. What's the inverse function? It's half of that. So y equals plus or minus square root of x. Which one do I have? Therefore, my inverse function, so the inverse relation will be the full graph, x is y squared, which looks like that. I haven't drawn it all, but which is y equals plus or minus square root of x. What's your inverse function? Which bit of the plus or minus do you have? The plus. So the inverse function will be y equals positive square root of x. Okay? So therefore the inverse function is y equals the positive square root of x. And what's its, I should do that in red. There. What's the domain of the inverse and the range of the inverse? Domain is, we'll swap, oh, it's going to be the same. Yeah, it's the same. X is greater than or equal to 0 for the inverse, and range y is greater than or equal to 0 for the inverse. Okay? Are we good? Okay. So with graphs like y equals x squared, if it's not if it's positive and negative gradients on the original function, you have to restrict the domain. All right. What about the other side of this function? what will be its inverse. So we're taking the right-hand side of that. I think you know what I'm going to do next. You sure you got all that? All right, let's just go to the other side. So let's look at y equals x squared again, but we're just going to look at this other side. So if we consider y equals x squared, but for values of x less than or equal to 0 this time. Got it? Just that side. Y equals x squared for values of x less than or equal to 0. So our domain is what? X is less than or equal to 0. Our range is y is greater than or equal to 0. We can draw the inverse ourselves. Let's do some points on the original function. -1, 1, -2, 4 on the original function. All right, how am I going to, with this type, it's really good to do the swapping of the points, otherwise you're going to end up drawing it really badly. Swapping -1, 1 becomes 1, -1, 1, -1, and -2, 4 becomes 4, -2. It goes like this, like these wings. Wait, that's the worst drawing. I think you know what I'm trying to draw. So this is 1, -1, and this will be 4, -2. And look, if you look at it like this, now, can you see it? Sometimes easy to see. That's a reflection in that line. If you folded the paper, that would sit on top of that. So of the inverse function, so the inverse function is, we know it's x, whoops. The inverse relation is x is y squared. That's my relation. Whoopsie. Inverse relation is that, which is y is plus or minus root x, but which one's your inverse function? Y equals the positive or negative? It's the negative square root of x. What's the domain and the range? You can just look at these and swap them. The domain should be x is greater than or equal to 0, and the range should be y is less than or equal to 0. I'm swapping. Is that true? X is greater than or equal to 0, y is less than or equal to 0. Okay. Yep. So that's the inverse relation. Be careful. This is the inverse function. The inverse relation is the full sideways parabola, which I haven't drawn. Inverse relation. If I do if I sketch y, x is y squared, it's the whole parabola, but we can't draw the whole lot. We just want the function. Homework's going to be the next 2 exercises. I'll send it to you.